So students, I was explaining the second part of the problem here, right? So the problem is a platinum resistance thermometer has a resistance of 120 ohm at 25 degrees Celsius. Determines resistance at 75 degrees Celsius. The temperature coefficient of resistance of platinum at 25 degrees Celsius is 0.0392 ohm per degree Celsius. In case the resistance of the thermometer is found to be 180 ohm, determine the temperature. So let us move on to the second part of the problem. So second part of the problem is let the temperature corresponding to resistance of 180 ohm be T3 degree Celsius. So formula is R3 is equal to R1 into 1 plus alpha 1 or alpha into T3 minus T1, right? So this is 180 is equal to 120 into 1 plus 0.00392 into T3 minus 25. We have to determine the value of T3. So 180 divided by 120 minus 1, that is equal to 0.00392 into T3 minus 25. So here what we will get? So this will be 180 divided by 120. This is equal to 1.5 minus 1, that is 0.5. So this is 0.5 divided by 0.00392, that is equal to T3 minus 25. So it is 0.5 divided by 0.00392, that will be 127. So it is 127.55, that is equal to T3 minus 25, or T3 is equal to 127.55 plus 25. So this comes out to 127.55 plus 25, it is 152.55. So 152.55 degrees Celsius, that is the value of the temperature T3. Fine. So this is the second part of the problem. Let us solve one more problem. Let's solve one more problem. Second one, a copper resistor having resistance of 15 ohm at 20 degrees Celsius is used to indicate the temperature of bearings of a machine. Determine the limiting value of the resistance. Determine the limiting value of resistance. Limiting value of resistance if the maximum temperature of the bearing is not to exceed 175 degree Celsius. The temperature coefficient of resistance of copper at 20 degrees Celsius is 0.00425 ohm per degree centigrade. Okay, so first write the given details. Read the problem first. A copper resistor having resistance of 15 ohm at 20 degrees Celsius. Write the given details. Resistance at resistance at 20 degrees Celsius, R1 is equal to 15 ohm, right? Temperature, then what else is given? The temperature of bearings of a machine is used to indicate temperature of bearings of a machine. Determine the limiting value of resistance if maximum temperature of the bearing is not to exceed 175 degrees Celsius. Temperature coefficient of resistance of copper at 20 degrees Celsius. So temperature coefficient of resistance at 20 degrees Celsius, that is equal to alpha, that is equal to 0.00425. okay, 0.00425. Next, initial temperature T1. What is the initial temperature? Copper resistor having resistance of 15 ohm at 20 degrees Celsius. So 20 degree Celsius. Final temperature, limiting temperature or final temperature T2. Determine the limiting value of resistance if the maximum temperature of the bearing is not to exceed 175 degrees Celsius. So limiting temperature or maximum temperature is T2 is 175 degrees Celsius. So we have to find the value of limiting resistance at this temperature. That's 175 degrees Celsius. So limiting resistance, that is R2, if we consider, that is equal to R1 into 1 plus alpha into T2 minus T1. Okay, so this is 15, R1 is 15 ohms, this into 1 plus alpha is 0.00425 into T2 minus T1. T2 is 175 minus T1, so it is 20. So let us, if we simplify this, so that direct it's a calculation here. So if we simplify this, then we'll get 24.88125 ohm. So that is the value of R2. Okay, so this is how we are getting the value of resistance R2, right, at the temperature, limiting temperature of 175 degrees Celsius. That is nothing but limiting resistance value at limiting temperature of 175 degrees Celsius is 24.88125 ohms. Fine. So students, in today's class we have started with the topic on viscometers, that is finding the viscosity. Okay, so we solved, then once after explaining the reflex viscometers, considering the Seybold viscometer, right, then we dealt with the electrical method of measurement of viscosity, various techniques used in the under electrical method. Then we solved two examples, right, on the formula, which is R2 is equal to R1 into 1 plus alpha T2 minus T1. On this formula, based on this formula, we have worked out two examples, right. So I hope everybody have understood, students. If there are any queries, send your queries to me. I will answer to your queries. Thank you.